Someone took all my web.
All right, so on this one, we're going to be solving. Here's what they're going to look like, just so that you guys know. First one, I'll give you kind of an easy one to start with. It's going to have x plus 25 equals 2. Now, when you're solving equations, if you've forgotten, because I know it's been at least 2 weeks, when you solve an equation, what you got to do is you got to make sure that you undo the order of operations. So, the radical symbol, or in this case square root symbol, is in fact a grouping symbol. So therefore, is there any adding or subtracting outside the grouping symbol?
No.
No. How about multiplying or dividing?
No.
No. How about exponents?
No.
No, not really. Okay? So then how do I get rid of square root? Square. So then you end up squaring both sides. Because remember, what you do to one side, you got to do to the other. So when you square a square root, what do you get?
X plus 25.
You get the inside. All right. And on the other side, what is 2 squared?
4.
4. Now from here, how do I solve for x?
Subtract 25 on both sides.
Minus 25. Now, one of the things that's going to come up is you're going to get some answers sometimes that might not work. Okay, so if I have 4 minus 25, I get negative 21. If you put negative 21 back in for x, does it equal 2?
No. Yes, I know.
You've got negative 21 plus 25. What's negative 21 plus 25?
4.
4. And what's the square root of 4?
2.
2. So we're good. So there's going to be some things, though, that you're going to have that are going to be called extraneous solutions that are not going to work. If they don't work, throw them away. If they do work, keep them. Okay, what if they don't work? What if nothing works? My answer is no solution. Good. Okay. All right, is there any adding and subtracting going on?
Yes. X minus 3.
Sorry, on the outside of the grouping symbol.
No.
No.
No. What about multiplying or dividing?
Yes.
Yes. What do I got to do? Divide by
2.
2. What's 4 divided by 2?
2.
Then how do I get rid of cube root? You cube it. All right. And on this particular thing, when you cube a cube root, what do you get?
X minus 3.
X minus 3 comes out. And on the other side, what is 2 to the third power? 8. Good. Glad you didn't say 6. Then, how do I solve for x?
Add 3.
Add 3. And what is 8 plus 3? 11. So when I get that answer, if I put that in there, 11 minus 3 is 8. The cube root of 8 is 2. And 2 times 2 equals 4. Did it work?
Absolutely.
Very good. What do you think so far?
Not too bad.
Not too bad for the first ones?
What's the catch, Mr. Lewis?
There's never a catch.
There's always a
There is not always a catch.
90% of the time there's a catch. C-A-T-C-H.
Okay. Is the square root all by itself?
Yes.
Yes.
Yeah. On the left-hand side, just so that you guys know, do you see where it's got x plus 1 now and not just a number?
Yep.
Okay, here's the catch. Okay? So, is the square root by itself?
Yes.
That's the main thing. And you said yes, so there's nothing more to do than that part. Now, how do I get rid of the square root? Square it. Okay, here comes the big catch. If I square the right-hand side, what do I get? 7x plus 15, and that's awesome. But when I square the right-hand side, that's a little bit different.
X squared plus 1.
What you end up having to do is you end up having to, and I saw Danny mouth it, she said FOIL. When you have multiple terms like that, write it out twice and FOIL it. Okay? So for that particular thing, it ends up being x plus 1 times x plus 1. And when I FOIL that, does anybody know what I get?
X squared plus 1.
X squared did that. Plus 2x
Oh,
plus 1. Remember? FOIL that out and then combine like terms. Now, what ends up happening here is I end up with what they call a quadratic, which you guys have done many times before. How do I solve a quadratic? Yes, you do. Quadratic formula is one option. Calculator is another option. Graph it. Hey, for the first thing, though, what I'm going to do is I'm going to move everything to one side. So I'm going to get all that stuff moved over. So if I subtract 7x and subtract 15, it might be easy to factor. I don't think you guys said that. What's 2 minus 7? -5. And what is 1 minus 15? And all that stuff becomes 0. So, in all reality, just so that you guys know, patients said use the quadratic formula, which is a good option. However, it becomes a little bit tedious. If you can factor it, factoring is faster. Is there anything that multiplies together to give you 14 but adds up to be 5? Or could be? -7 and plus 2. What times what gives me -14, but adds up to be -5? -7 times 2 is -14, but when I add them, I give me -5. Now, when I put them each equal to 0, what do I get? I get 7, and I get -2. Okay, so after I set them each equal to 0 and add or subtract the numbers over, that's what I get. Great. Do they both work?
Yes.
So let's try. On the 7, for instance, okay, the original problem was x plus 1 equals the square root of 7x plus 15. If I put 7 in there, 7 plus 1 equals the square root of 7 times 7 plus 15. What's 7 times 7? 49 plus 15? What's 49 plus 15? 64. And the square root of 64, does that make 8? So we're good there. What was the other answer we got? What's 7 minus or times -2? -14 plus 15? 1. What's the square root of 1? Square root of 1 is 1, right? On the left-hand side, -2 plus 1 is -1. Does -1 equal positive 1? No. So guess what I get to do with the -2?
Throw it out.
Scrap it. Yep, throw it out. So the only answer I get to keep is the number 7.
So we have to figure out if it works.
Yeah. Because not all the time are they going to. Now, what would happen if I would have had to scrap both of them? Then my answer would have been no solution. Right? Okay? What do you think? First half of the assignment is just a number on the one side. Second half of the assignment is one like this, where where you might have to square both pieces like that. Trying to think if there's anything else yet. This one's bark is worse than its bite. If you have square root on both sides,
Square both of them.
okay? Again, for this particular thing, if you tried to have it where if there was anything on the outside or anything like that, we'd still have to FOIL. But when there's only one square root on the left and one square root on the right, square root or square both sides, guess what that does? So that cancels out. What do I have left?
4x plus 1 equals.
Not as bad as it looked, right? Okay, now what? How do I solve it? It's not a quadratic this time, so it's just for x. How do I solve for x? Subtract x. If I'm moving the x's to the left, then I probably want to move the numbers to the right. So I would subtract 1. Only because the way you were saying it, Jay, is that would, if I had a quadratic, then yes. But because I don't have x squared left over, x is to one side, numbers to the other. So what's 4x minus 1x? 3x equals 9. Now what? Divide by 3. And what's my answer?
3.
Does it work?
Yes.
When you plug it in, 4 times 3 is 12, plus 1 is 13. And on the other side, 3 plus 10 is 13. Square root of 13 equals the square root of 13. Is that true? Yeah. What if it wouldn't have been true?
No solution.
Then you throw it away. And if there's the only answer that you get thrown away, then it's no solution. What do you think? Not too bad? Okay, because that one was right out of your assignment. Do you want to do any more? Are you sure?
Is there anything else we see?
I don't think so.